To solve this problem, this one's set up really nicely to be able to solve it without even looking at new techniques or anything, because I want to just be able to figure out what x, y, and z are, but you'll notice that this one is set up to where we can easily figure out first what y is at least, because we know that 2y has to equal 12. Alright, so basically I'm taking this 2y equals 12 and I'm solving that, so we're going to divide both sides by 2, divide both sides by 2, so we know that y equals 6. And yes, this is the kind of work that you'd want to be showing. Now once we know that y equals 6, what can I do with that information? Yeah, we can plug it into one of the other equations, or even both of them for that matter. But most useful would be plugging it next into this equation, the second one. So if I take that y equals 6 and plug it into that second equation, you'll notice that what happens is I end up with 7x minus 10 times 6 equals a negative 25. You notice there's only one variable now. That's what we want. If there's only one variable in one equation, I can solve for that. All I got to do is just do the algebra now. And so we got 7x minus 60 equals negative 25. Yes, you still want to show all of your algebra as you go through these problems. Helps keep everything straight, because as you can see, if you make one mistake early on, it's going to cause a lot of problems later, isn't it? Alright, so we go through all that, we end up finding that x here equals 5. And so now that I know that x equals 5, how do you suppose I'm going to find z? Yep, we can plug both the x and the y in to the bottom equation here. And so I'm going to plug both of those in, because if I plug both of them in, I'm going to be left with an equation that has only z in it. And so let's go ahead and do that then. So negative 4 times the 5 minus the 6 plus the z equals a negative 29. And so we're just simplifying as much as we can. When you're doing these problems, you want to make them look like stuff you've dealt with before, as much as possible. And so simplify, combine like terms, and then go ahead and move the numbers to the other side. And so you notice that when we do that in this case, we then find that z equals a negative 3. We've now figured out all three values. And so for our final answer then, we just listed out kind of like what we have up here. We're just going to say x equals 5, y equals 6, z equals a negative 3. And we're done. Now, a little side note here. When we were solving before, we often would give our answers as a coordinate pair. So we'd do like x comma y in parentheses. You can technically do the same thing with this. If you were going to, it'd be x, y, z. And technically speaking, you can represent it this way, but we tend not to, because this is actually a point off in space on a three-dimensional grid, but we don't actually do a whole lot of three-dimensional graphing, right? And so we tend to just say x equals y equals z equals for that reason. But yes, you could, and it also has another interesting application if you like bending your brain a little bit. You technically could actually graph each of these three equations on a three-dimensional grid, and they would all cross at this point. This first one was a nice, easy one. This one we didn't really need any new techniques, anything special, but we are going to need to see how to deal with more difficult ones. In fact, by the end of the week, we're going to be dealing with systems of three equations where every single equation includes all three variables. We just need to build up to that and develop some of the skills along the way. So we're going to start down that road with this problem. So go ahead and write this one down on your paper, and as you do so, make sure it's accurate. Like, write it down, then double check it. Now for this one, most of you can probably figure out, okay, well, at least I know what to do first. Because you notice we do have one equation here that has just one variable. I can solve that one. So I'd start by doing that. If I have something easy that I can do right off the bat, I do so. So I'm going to go ahead and divide both sides then by the negative 7. And we should find here that z equals a negative 2. Great. But now that I know that z equals negative 2, how do I solve the rest of it? Well, let me give you a little bit of basic idea here. You notice that when we have one equation with one variable, I can solve that. Before today's work, we had systems where we had two equations with two variables, and we were able to solve that. Similarly, if you have three equations with three variables, you can solve that. Basically, if you have as many equations as you have variables, it's solvable. And so in this case, what we're going to do is we are going to now turn our system of three equations into a system of two equations. Because I know what z is. Look at those other top two. If I plug z into both of those, then there's only two variables, right? So that's what I'm going to do. For the first equation, I'm going to take negative 3x minus 6y minus 5 times my z value, negative 2, equals 19. And I want to make this look like the sorts of simple equations I've been working with for the last week. In other words, I just want x and y by themselves on the left side. So we're going to do that. So negative 3x minus 6y plus 10 equals 19. Keep working at that. Remember, we're trying to get the x and y by themselves over there, so it looks like what we're used to. And that's a great rule of math. Anytime that something looks odd, make it look like something that doesn't look odd to you. Make it look like something you're used to working with. All right, so I changed the first equation so it only has two variables in it. I'm now going to do the same thing for the second equation as well. And so when we do that for that second equation, we can end up with this. 8x plus 6y equals negative 14. And so the reason why I did all of that work was to make the first equation and my second equation here, which used to have the z's in them, make them look a lot simpler. So now notice they both are equations that are just in terms of x and y. So I've basically created for myself a new system, negative 3x minus 6y equals 9, and 8x plus 6y equals negative 14. A new system with two variables and two equations. By plugging that value of z in, I created now a system that's like what we were used to dealing with before. Because again, if it doesn't look like something you're used to, make it look like something you're used to, if you can at least. In fact, I bet you know how to solve that one already, right? That's what we were practicing last week. So go ahead and finish this problem off. Please solve that system for x and for y. You should then get an answer of x and y both equaling negative 1 and z equaling negative 2. Yes, that can happen. Certainly it doesn't happen every time, but yes, two or more of the variables can be the same. It's just kind of a matter of chance if they are or aren't. All right, and so now we hit this problem. And this problem is not nearly as obvious about how to go about it. Because in the previous two, we always had either an easy x, y, or z equals just by itself. We could solve just one. So we need a new strategy then. How do we do it? Well, I've been talking about how whenever something looks weird, you want to see if you can make it look like something you're used to. We could do the same kind of thing here. Because yes, if I'm going to solve for three variables, I need three equations. And so I need all three of these to solve for x, y, and z. But notice here at the start, I have two equations that each have the same two variables in it. So what I can do is I can actually just use those two equations first to solve for y and for z. So I'm just grabbing these two out at the start. And so write them down. as their own system, and since they are their own system, keep that curly bracket next to it. Notice then we have a system of equations that we can now solve by elimination. So please solve that system by using elimination. All right, so I chose to solve this system by multiplying the first one by -10. Again, there's different ways you can go about it. But when we do that, you notice I ended up finding y first, so I found that y was 4. Then once you know what that y value is, plug it back into one of the original equations. Now again, choose one of them though that only has y and z in it. If I tried to plug that back into this one right now, I wouldn't be able to know what the x is or the z is. All right, so I plug it into either one of these equations that I used right here. At this point, we then know that y is 4 and z is -6. Now that I know that, how can I find x? Plug them in. Yep. And this is where I then have to use that third equation. You notice every equation will get used at some point. It's just a matter of when. So the x is still just an x, but then I can plug in for y, and I can plug in for z. And then just solve that out to see what x is. And so when we do that, we end up finding that x equals 1. And so then that's our final answer of 1, 4, and -6.